Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we appreciate your time today. Today's topic, 10-minute Corona Treater inspections to prevent downtime. Today's panel, Matt Rajala, Enercon Service Manager, and Tom Gilbertson, Enercon's VP of Application Engineering. Together, Matt and Tom have nearly 40 years of experience with corona treating and surface treatment applications. We have a lot of material to cover today in a short amount of time, so I'm going to turn the presentation over to Matt.
All right, good morning, Alan. Thank you for joining us. Today we're going to, basically the purpose of the webinar this morning is going to be to, basically discuss the standard checks, kind of quick checks, brief checks. I certainly wouldn't want to take much away from your production time or anything, so kind of the purpose of this is just get in there, just do a few minutes worth of checks, which will go a long way in preventing downtime, preventing any equipment problems, and also preventing real time consuming and labor intensive cleaning if things are neglected for several years. So this just kind of shows an overview of the program we're going to go through. We're going to talk about just kind of make mention of manuals and stuff because, again, always, if there's any questions, always refer to the manual or feel free to give us a call. This webinar is just kind of put together as to kind of bullet point some of the key highlights from those other resources. We're also going to discuss again why weekly inspections are important, such as like we were talking about, to prevent basically enhance the life of your equipment and also possibly reduce, in the long run, reduce your time doing preventive maintenance by, not letting stuff accumulate and, dirt accumulate to the point where it's going to be time consuming to clean. We'll go over some of the Corona Treater basics, as far as the major components in the system. We're going to go over power removal and safety, and, because that's always, obviously we want to put safety first. Just want to kind of outline, what exactly to pay attention to make sure that when you are doing these inspections that we're doing it all safely. We're going to go through then the specific inspections, of various components of the treater station, such as the electrode assemblies, the ground rolls. We're going to also discuss grounding and terminations. Typically, that's all checked right from the get-go. If it's not, it's certainly this kind of opens a discussion to at least get them checked initially, and then down the road just kind of periodically peek at those items and make sure everything is still in good shape. Then we'll basically just review and recap what we went through, and then we're going to have an opportunity for Q&A. So I certainly invite you guys to ask any questions, and we'll be glad to answer them. Hopefully at this time, or either way, we'll follow up one way or another and make sure your answers are your questions are answered. So always, again, this webinar is basically the key highlights, but for more detailed description, certainly always reference your Enercon Corona Treater manual. If you don't have a copy of your manual, you can always contact us here at Enercon 262-255-6070, or you can contact myself, Matt Rajala, or Tom Gilbertson, and we'll be sure to help you out by providing you a manual if it's been misplaced over the years. Now we'll start getting right into it. This is just kind of showing the key building blocks of the Corona Treater system. We got the power supply, which is going to take your utility line, which is going to be 240 or 480 volts AC. In some examples, different voltages, but it's going to take that in whatever the rating plate says, and it's going to take that line voltage at the 50 or 60 kilohertz frequency. And what that does is basically it's going to convert that to a high frequency AC output, which is going to be going down to the high voltage transformer. That high voltage transformer basically takes the that high frequency signal source from the power supply, and it's going to step that up to 10,000 volts. So the high voltage transformer steps it up, that high frequency high current, low voltage output from the power supply and steps it up to 10,000 volts, which is brought to the potential of the electrodes, which is shown above the ground roll here in the picture. And so that's going to provide the potential, 10,000 volt potential, which is going to do the effective work of treating your material and increasing the dyne level and surface tension of the material that you're trying to treat. And as you see, the ground roll kind of completes the path of that high voltage. So it's always important to make sure that the ground roll is, solidly connected to an earth ground, being the final return path of that power. So, well, like we talked about, and kind of we mentioned a little bit before, but the question is, why should we perform weekly inspections? There's certainly various reasons. We want to make sure that make sure that we're just kind of getting in there quick, peeking, checking the status of everything, making sure that because usually, and every facility is going to be different. One facility will be different from another because it usually comes down to how clean or dirty is the ambient air in the facility. But usually a week is a good reference to at least kind of take a peek and see what the condition is and the status, and quickly wipe down things, clean everything out to prevent any severe accumulation that may occur after months or even certainly years. Could lead to more excessive.
And Matt, this is Tom Gilbertson speaking. Just to interject here real quick, there's another component. Obviously, as Matt's indicated, making sure the treater is in good condition helps its performance and safety. But there's an application side to this. If the Corona treater is not functioning properly, or for various cleanliness reasons isn't operating to its best, that can also be seen in a problem with application, an adhesion problem, a dyne level problem, maybe an uneven treat situation, whatever the case. So keep in mind that as Matt goes through the program here, it's important both from an equipment standpoint and uptime standpoint. It's also very important from an application standpoint.
Thanks, Tom. Yep, and that's certainly true as we see. It could lead to poor treatment, could lead to application problems, could lead to a variety of things. Certainly also, roll covering failure. Anything that might be, any of that accumulation debris is, can lead to localized heating in certain spots due to, just the fact of having carbon. Anytime you have carbon or dirt or, some organic material that's just kind of sitting and hanging out, where you're exposing that to, high voltage, 10,000 volts, that can certainly, become conductive, carbonized, and lead to localized heating and shorten the life of things. So that's definitely something to keep in mind. Another thing, kind of, some good reasons to check the electrodes and electrode assembly. Again, we want to enhance the ultimate goal here is to enhance the uptime and enhance the prolong the life of your equipment. So, making sure it's, if you neglect it, it can shorten the life of the electrodes. It can, basically reduce the amount of, basically the work of the exhaust system to remove the ozone from the working environment. So definitely you'll be safer by just making sure everything is clean and in tip-top shape to remove, the exhaust and for cooling and ozone. And also, other things would be, just check out the high voltage wiring and insulators. Make sure that that's all kept clean so you don't have that accumulation and again, localized heating, carbonization of materials there.
Matt, I want to just kind of highlight one feature that you did focus on, only because I had this phone call this week actually, and it relates to the ability for the treater to evacuate the ozone. As everybody who's on this webinar most likely already knows, a byproduct of generating Corona is ozone. And ozone is a very corrosive gas, and obviously we don't want it in the workplace. And so by making sure that the electrode assembly is clean and that our exhaust path is free, it ensures that no ozone gets into the plant environment, thereby affecting, safety-wise, affecting any operators or plant personnel that happen to be working around the treater. So yes, it does also benefit the cooling of the treater, and so there's an equipment benefit there, but as Matt said earlier, and to focus on it, really a safety standpoint here, we want to make sure that the treater electrode assembly can do its job, effectively removing the ozone right at the point with which it's generated. Matt?
Yep, for sure. And let's see, here's an example of a neglected ground roll. You know, this might have occurred, well, most likely would occur over some time of not performing, you know, regular cleaning and inspections, and, you know, say the weekly, you know, 10-minute inspections and cleaning. So, you know, example of this shows, you know, again, this is certainly not ideal, and in this case, you know, this has kind of gotten to the point where, you know, the amount of time to clean this is, you know, going to be a little bit more of a procedure, and you can certainly, you know, check out our maintenance webinar, or, you know, give us a call, or check out our website for, you know, proper procedures as far as, you know, cleaning this kind of grime off. You know, it is going to be, you know, take a little bit more time to get that fully clean. But again, the purpose of this webinar is to kind of prevent this from occurring in the first place by just, you know, taking a few minutes here and there on a regular basis to check the cleanliness. And here's an example of neglected electrodes. Again, you know, this is showing, you know, what can result by not taking these proactive measures of, you know, just spending a few minutes every week, kind of wiping down, cleaning out, vacuuming these components of the system. So, you know, this is just basically, again, the main thing that we're trying to prevent here by addressing this topic this morning. So again, now that we're gonna, you know, begin our inspections and, you know, our quick kind of cleaning and status check, the first thing we want to do is going to be remove the power, make sure that we have a safe working environment, you know, safe for cleaning and everything. So power removal, in this picture shows basically the breaker of our power supply being locked out, tagged out. I would certainly not want to override any of your local, you know, lockout, tag out procedures. So certainly, you know, follow whatever you guys are already doing. But in addition, this is just kind of speaking specifically to the Corona treater. You know, you want to make sure that the breaker on our power supply controller is shut off and locked out. Also remove any power upstream. So generally there should be, say, a disconnect box, power disconnect upstream of our power supply. Also make sure that's shut off. And also de-energize any station pneumatics. So before you're doing any work, you want to, you know, there's probably going to be a ball valve or something to shut off the compressed air, and then make sure you bleed off the compressed air lines just so you're not, you know, having any stored potential there or anything like that. So, and, you know, a good question, the reason we're talking about this is, you know, basically at minimum, anytime work is being done, maintenance is being done to the treater station, and when I say treater station, that's the ground rolls, the electrodes, you know, that area. At minimum, we want to make sure that the power, you know, our power supply is locked out and tagged out. You know, for example, as the power supply is shown here, and as long as the power supply is shut off, it is going to be safe to work on the treater station. Because and you can basically work on it right away. There's no charge stored in the high voltage transformer or anything like that. And the reason is basically once the power supply is shut off, the inverter, there's no chance of the inverter firing or anything like that. And then basically the primary side of the high voltage transformer is basically it's just a coil, it's shorted. So you basically have a short circuit on the input of that, and so there's not going to be any charge left on the output. Something I should probably mention though is, you know, and this would be more from environmental situations, but there might be, maybe there's a static charge on the line or something, and that's going to be unrelated to the Corona treater. So, you know, again, just make sure that, you know, if you are working, and if you have a lot of static charge in your plant, you probably already know about it. But, you know, that's just one thing that you do feel a tingle or something, if the power supply is locked out like this, then it's probably some type of static charge, maybe from the friction of the material moving and stuff like that. So just keep that in mind. And then we talk about, if you're going to work inside the power supply, if you're just, opening that up to check inspections, in that case, you will definitely need to make sure the power upstream is locked out. And also, you should wait 5 minutes for the power supply to completely de-energize. So that's information on that. Now we'll get into, again, after everything's locked out and everything, we'll talk about inspecting the electrode assembly. The first thing we want to kind of overview is going to be the design in which our electrode assembly functions. All right, so this is showing the how the exhaust airflow is concentrated in our efficient design to effectively cool the electrodes and to remove the ozone. So the first thing we want to do is we want to check and record the air gap, because before we do any maintenance, we want to just get a baseline, make sure we have it documented and recorded as far as what everything is set to before we begin work, just so we can return to that baseline if need be. This just shows when we first pivot the electrode assembly out of the treat position, take a look at the face of the electrodes, wipe them down with isopropyl alcohol. Look for any obvious signs of damage or dirt or anything like that on the electrode surface. And one thing that we have, any of our systems, say in the last 10 years or maybe slightly longer, we have a convenient hinge designed to hinge that electrode assembly open, and so you can basically expose the underside of that, the cooling air ports. And the next few slides will kind of outline as far as how to hinge that electrode assembly open the proper way. Right, and basically this assembly shows the locking knob here, which is the maintenance locking pin. And again, this applies to the our wide web Corona treaters. We have a maintenance locking knob that you basically would pull out and rotate, say 90 degrees, to allow that electrode assembly to pivot open. And then once you get that open in the maintenance position, you want to drop that black maintenance locking pin down to make sure you're locking the collar, so then that electrode assembly is out of the treat position. So then you can basically work on and perform the cleaning and everything with the electrode assembly out of the treat position. And so to basically hold it in place while you're carrying out the maintenance. We also have these latches that you can basically go through. It goes down the length of the electrode assembly. Loosen those, and that's going to allow the electrode assembly to pop open. So then we can, as shown here, shows that we can, it exposes the underside of the electrode assembly, and we're allowed, enabled to clean the exhaust cooling ports and everything. And again, this is basically, we're going to look for debris on the insulating shroud. We're going to wipe that off with isopropyl alcohol and a lint-free rag. We're going to wipe down the electrodes, the ceramic electrode bars. We're going to wipe down the exhaust cooling ports that go down the length of the exhaust tube. One thing that we might want to do is, if you do have some buildup, if there's any material, stuff like that there, take a shop vac to vacuum out that area, or you can use an oil-free compressed air to just kind of blow out any debris and get as much stuff out of that area as possible to keep it as clean as possible. And again, this just kind of outlines what we were mentioning as far as cleaning that out. Just lint-free rag, isopropyl alcohol. You can use mild soap, but again, always make sure you follow it up with an isopropyl alcohol rinse. And now we're going to get into station inspection of basically the ground roll. So this is going to be, again, a ground roll that we're inspecting about, once a week. Just wipe that down with isopropyl alcohol. You can use also any type of mild soap. You can use any type of household kitchen and bath cleanser to wipe it down. So anything like that, anything that's non-corrosive. And again, for more detailed instructions as far as cleaning that, you can check out our maintenance webinar or refer to the manual. And yeah, basically this is just like we talk about. We want to do this regularly to prevent prevent a more extensive cleaning.
And Matt, I think as the picture shows here, we're showing in the example here, we're showing someone using a Scotch-Brite pad to help clean that roll, which is the preferred method. One comment here we want to make sure everybody understands: on the electrodes, ceramic electrodes are on the ceramic roll. You don't want to use anything metal. No metal tools, no brushes, no steel wool, nothing of that sort, because that will leave metal bits behind, and those metal bits become conductive, and therefore can cause some further problems once you re-energize the system.
Yeah, very good point. Very good point. And a very common question we get sometimes too. So let's see. And it's always, anytime you have a covered roll, it's never a bad idea to stock a spare roll, because sometimes those are generally they're custom-made rolls, the ceramic ground rolls and stuff like that. So always having a one on hand is spare is always a good suggestion as well. All right, and then once we're done cleaning, just kind of wiping down and doing our quick inspections on the electrode assembly and the ground roll, we want to make sure basically go back and remove that black maintenance locking pin that we looked at before. Make sure that that's unlatched and allowing the electrode assembly to pivot freely. And the reason I mention that is some people mistakenly think that black maintenance locking pin is to lock that in the tree position, which is not what you'd want to do. Instead, you want to always make sure the electrode assembly is freely moving, that there's no mechanical restrictions once you go back into production. So always make sure that it's in the tree position, but more importantly, make sure that electrode assembly is moving freely. If there is a mechanical restriction, then you might need to drill down and see why it is, whether it's something locking it in place, or if it's something maybe the exhaust tube bearings need to be replaced, or something along those lines. And again, once we're all set, we want to again check and record the air gap, the electrode air gap. We do recommend 1.5 millimeter or 60 thousandths between the ground roll and the electrode. So again, or you might want to go back to your baseline, whatever you guys use there. But our recommendation is 60 thousandths of an inch. And if it does require electrode gap adjustment, again, that's going to be another procedure that is outlined in the manual, or other forms of media that we offer, or you can always call and ask us. And then just a few quick checks is going to be, since we're in there anyways, let's just check out the earth grounding and terminations, since that is very key with the system. This just shows two examples of our ground brush, which is making good electrical contact to the ground roll, to the journal of the ground roll. Make sure just wipe down the brush points with isopropyl alcohol. Clean it up as good as possible. There's no need to use any type of conductive grease or anything like that. You wouldn't want to collect any more dirt than need be. You want to just wipe that down clean with isopropyl alcohol, and make sure that the ground brush is making intimate contact with the journal of the ground roll. You also want to make sure that there is an earth ground wire terminated to the frame of the station. And our newer systems, the last few years, we actually have a specified point for earth ground termination. But basically, it's just as simple as removing the paint at a location of the frame and just terminating an earth ground wire to that. That way, you're just not relying on the earth ground being terminated through bolts and threads and stuff like that. And then this is inside the power supply. This is just a real quick thing that we want to do is, again, with all the power removed, especially upstream of the power supply, just open it up, look for any dirt or debris, vacuum it out, blow out with oil-free compressed air, and just look for any signs of burning or overheating. If you do find connections that are burned or overheating, It's likely because that connection is loosened up over time, so then you would just want to, if you do find that, just take the corrective measures to re-terminate it or whatever the case may be to prevent any further problems down the road. And yeah, so basically this is just a review. You know, as we talked about, just quick inspections that we want to do on a regular basis. Always consult the manual or call Enercon if there's any questions. Like we talked about, we always want to do all of this safely. Just check for any signs of dirt, debris, evidence of arcing or overheating, and yeah, basically just and if you do find anything again during these inspections, you know, I wouldn't want to, you know, distract from doing these inspections. So certainly do these regularly, but if you find anything more major, you know, then schedule the appropriate downtime to address maybe more serious things that are found.
All right, thank you, Matt and Tom. We're now going to take some of your questions. You can use the question tool to type them in. We'll get to as many as possible. Also, please know that this webinar is being recorded, and in a few days when we have it posted online, you will receive access to the both the recording and the webinar slides. There's also some valuable information on the screen relative to contact information and phone numbers should you want to follow up with us after the webinar. The first question we have deals with the air gap and how can you determine what the air gap is?
Okay, yeah, that's a great question. We do offer air gap gauges, which are basically just like plastic feeler gauges that are 60 thousandths inch thick or 1.5 millimeter thick. So basic, and it is outlined in the manual, and I'd also encourage you to check out our maintenance webinar. We do go through some of the procedure there that does show the adjustment points to adjust the electrode gap. But basically it's just by means of, with the power off, just taking a plastic, again, non-conductive feeler gauge, just a plastic feeler gauge, which is 60 thousandths thick, and just referencing, just sliding that in between the electrode and the ground roll and checking that that gap is set accordingly.
We have a few questions related to cleaning of ground rolls, specifically why Scotch-Brite pad would be used and what the damage that could happen if you were to use metal.
Oh, great. Yeah, that's a good question. Scotch-Brite pad is the best thing to use. It's basically a scouring pad, non-metallic scouring pad that can be used to, it's a little bit, well, it's certainly more aggressive than a lint-free cloth, and that's going to do a good job as far as removing any accumulated dirt or debris that's on the surface of the ground roll. Again, you want to always use something non-metallic cleaners. If you were to use a metallic cleaner like steel wool, which we do not use that, but if you do use something like that, what can happen is little bits and particles of that steel wool can actually be left behind or maybe even embedded in the ceramic surface. And then what you're going to have is these little localized tiny pockets of conductive metal that's going to be exposed to high voltage, and it's going to shorten the length of the life of the ceramic ground roll covering.
And Matt, if it's a bare roll metal ground roll, what should they use?
Oh, okay, just a bare aluminum ground roll. They can use any type of metal cleaner to wipe that down. They can use isopropyl alcohol, anything like that. But if there's severe oxidation, which is going to happen after some time with the bare aluminum roll, severe oxidation, the best thing to do for that is just basically bring it to like a local machine shop or something. They can just do a skin cut typically on that. Maybe just start with about a 1,000th skin cut, 1 to 2,000 skin cut, just to kind of clean up that surface.
And then, Matt, what they ought to do following that is maybe contact you or Robert in parts and talk about possibly getting that roll coated with a conductive ceramic. Therefore, in the future, they wouldn't have that oxide buildup, right?
Yeah, that's true. Yep, good point.
Tom's got an application question, wondering what the thinnest gauge film that can be treated.
Well, that's a good question. Really, the treater, there is any gauge film can be run through the treater as long as you can hold tension on that film so it conveys through the treater. The gauge of the film really doesn't have any impact relative to treatment. And as to follow that up with air gap, where should the air gap be under that condition? As Matt indicated earlier, 60 thousandths is really a great place to start. The film thickness overall really doesn't have a particular impact relative to the air gap. As long as the film thickness is anywhere from, say, a quarter mil all the way up to 30 or 40 thousandths, in those instances you would never have to change that 60 thousandth air gap. It'd be very, very unusual for that to occur. So our recommendation is, if the air gap is at 60 thousandths, if the electrode assembly is uniform over the treater roll, no reason to to adjust it.
Tom, another question regarding making sure that you have even treating across the web. I guess in this case, what would be some of the causes that could create uneven treatment?
Well, in our particular system, the number one cause is just simply an air gap that's uneven, meaning that maybe from one side to the other, one side might be 60 thousandths, the other side could be 20 thousandths. Corona being what it is, it will always go to the path of least resistance. So the closer the electrode is to ground, you're going to get a greater density of discharge there, and the further it is away from the ground roll, you're going to get less treatment there. And so depending on what the film is, your dyne level may not be uniform in that particular case. So make sure your air gap is uniform. That will pretty much take care of dyne level uniformity. Well, the other question on here is, and I saw this, what effect does dirt buildup and powdery buildup have on the treater roll? If the web runs over that roll surface and it has lumps and bumps all over it, you're going to get air behind the web. And if you get air behind the web, you're going to ionize that air and you're going to get corona behind the web. And many times that corona behind the web is not desired. Sometimes it can lead to an increase in dyne level, which may not be desired. Other times it may lead to a decrease in the dyne level of the side that you want to treat. And that of course, isn't desired either. So making sure that ground roll is good and clean, as Matt indicated, goes a long way to helping you make sure your dyne levels are uniform.
I've got time for one or two more questions here. The next one is, someone is seeing a white powdery buildup on idlers after the Corona treater. What could cause this? They are treating a PET substrate.
This is Tom again. Not an unusual sight. You see this on film extrusion lines a lot. Essentially what happens here is the Corona is kicking up additives that happen to be on the surface of the film. It loosens those additives as the film is conveyed through the treater onto the next side of the roll. Those additives tend to accumulate on downstream either rolls or downstream hardware from the treater. Many times you'll see this phenomena principally on blown film extrusion lines, but it's also seen on other pieces of equipment.
Thanks, Tom. Our final question, and this is probably a good one to end on, Matt. How often does this type of cleaning have to take place? And I imagine the answer might be different based on the environment the treater's in.
Yeah, that's true. Now, what we're suggesting here and what our manual suggests is to do this type of cleaning, at least just the quick checks and inspections on a weekly basis. Now, depending on your facility, if it's a very clean facility, if you're not, basically if you're opening up the electrode assemblies and checking the condition of the ground roll on a weekly basis and it pretty much looks unchanged on a weekly basis, then in that case you might want to check it monthly then, or just basically increase the time between checks accordingly. However, checking it weekly initially is going to give you a good kind of knowledge as far as how dirty, how much dust is accumulating within a week, and then adjust accordingly.
Thanks, Matt. We're going to cover one more question. It had to do with ozone. This particular person says that the ozone fumes are being inadequately exhausted from the Corona treater, and that is leading to a spread on the shop floor.
It's a great question, and it's funny, again, I just addressed this with another client earlier this week. So there's two reasons for this to happen, and you hit on one of them. One of them may be an inadequate exhaust rate from your exhaust blower, meaning the exhaust blower's got some leaks in it or something some malady with the blower itself. Second point, it could simply be that due to the line speed and the type of film that you're treating, that fugitive amount of ozone molecules are stuck to the web. And this happens on nylons and polyesters with some frequency, particularly on lines that are running hundreds and hundreds of feet a minute. Sometimes you'll smell that ozone as it can collect at the winder of the press or of the laminator. And what do you do to mitigate that or to help it? Sometimes simple air movement, just placing a fan around the treater, just to get the air to work around the treater. Any residual ozone molecule that happens to be near the web as it exits the treater just needs to be moved around. Ozone's a very reactive molecule, very unstable, and it can be taken care of quite easily. But the first thing you do is make sure your electrode assembly is clean, that you're getting the proper exhaust rate, and make sure your blower is operating properly.
Thanks, Tom. And thank you to our audience today for spending the time. If we did not get to your question online, we will follow up with you via email or with a phone call. Once again, we appreciate your time today. We hope you learned something that will help you in your operation of your Corona treaters.